Hello, I am Alessio Caiazza from the delivery team, and I'm going to talk about hands-off production deployment at GitLab. So, first the question, why don't we deploy automatically to production? Our deployment process is gated by human decision, so release manager have to make several choices in order to promote a build to production. First of all, we have manual checks to perform. So we are looking for errors and new errors. Also, we don't have a good strategy for rollbacks, which has it's very important in the human decision of a release manager, because they need to be around for an extended period of time to just make sure that if something goes wrong, they are available to help in resolving the situation and providing all the contextual information about the deployment. And finally, we rely on human intervention for aborting an ongoing deployment and restoring the system to a healthy state. Why do we have manual checks? So before 3 months ago, only the engineer on call could authorize deployment. So we already had a first human decision outside of the release manager. Now we have a new process, and we are keeping track of active incident and active change requests with GitLab issues, so we could evolve release tools to check those information and make the first decision if it was a good moment for starting a deployment. But we still have a manual check, which is error checking. And we have a problem here because detecting new errors is hard. Our Sentry is full of fake new errors each release, and this is not a reliable way for checking errors, and is not reliable as a human check as well as automating it. So looking at our production dashboards, we have other metrics that we can use for checking for errors. So we are using multiple burn rate alerting window, and with this thing we have monthly error budget, and we are counting the number of errors over a period of an hour and 6 hours. And basically, if in 1 hour we are burning more than 2% of our monthly budget, we will end up violating the budget by the end of the month. As well as in the 6 hour window, if we are over the 5% of the monthly budget, we will violate the budget by the end of the month as well. So we came up with this idea of having a new threshold, which is more sensitive than the one that we are already using for production deployment. So right now we have 3 thresholds. The first one is for customer SLA. Then we have another one which is more sensitive, which is for paging the engineering on call. And then the third one that was introduced recently, which is only for automated deployment, which is a higher level of sensitivity. Then, why don't we have a good strategy for rollbacks? Database migration are a blocker for rollback. If we take a look at this schema here, so here there's a timeline of a deployment, and basically we have a machine, which is the deploy box, that runs migration. So we can think about this timeline when we have database running schema A, then the deploy box run the migration, and the schema is schema B. So as soon as we have the new schema, all the machine can start rolling out the new code. So we are switching from version N to version N+1. Then we reach a point here when we start running post-deployment migration. So we start running post-deployment migration as soon as every machine is running the new code. So version N+1. And this means that when we are on schema C, this is no longer backward compatible with the old version of code. So this is a point of no return. As soon as we have schema C, we can't go back with the old version of the code. There's also another thing worth mentioning, that if a migration requires no downtime, it doesn't mean that reverting it requires no downtime as well. So even removing post-deployment migration from the equation, we can still think about rolling back code, but is not feasible to consider also rolling back migration at this point. So we may say that we can run version N, so the previous one, with schema B, which is the new one, in case of an outage. And finally, why do we rely on human intervention? So prior to daily auto-deploy, we used to deploy big change set. And with the big change set, we had a high chance of having post-deployment migration. So this means that every deployment have a point of no return because of those migration. So we were not able, in any case, to consider a rollback, but only patching and rolling forward. So because rolling back was not an option, we needed humans to fix the system. And having human already involved in the process made it easier to think about writing rollbacks instead of writing automations that were kind of premature optimization. So, state of the art in the industry. On the right side, there is a list of reading and watching materials of what other companies are doing. And their mileage may vary. Some of them are using microservices, others are using a completely different stack, technological stack, but they are worth reading. And I'm trying to outline the common techniques that are available in all those reading and watching materials. So the first thing is that keeping the change set as small as possible. And we are already doing this with increasing the frequency of new auto-deploy branches. Then it's clear that we need the ability to safely roll back. And we need to be able to prevent a deployment if the system is not healthy, as well as we need to be able to promptly detect anomalies and commence an automated rollback. Then phased rollout with baking time are useful for spotting anomaly before completing the production deployment, which means that we are restricting the blasting radius of a change set that introduced new errors at the first machine in the fleet, instead of going all in through deploying in the whole infrastructure and then having to roll back every single machine. And then another interesting tool is load testing in production. So basically it's the ability to steadily increase the traffic to one specific node. We can think about canary, for instance, in our case, so that we can compare metrics with the new version and the rest of the fleet and make decisions based on that. So hands-off deployment, why now? In the last few months, we reached our average MTTP goal of 24 hours. We could lower the goal and increase the auto-deploy branch creation frequency, but it's unrealistic to have more than 2 or 3 hands-on deployment each day. The span of attention required by an engineering and release manager during a deployment is really high, and it will just be not really safe to do more than what we are doing now. And also, increasing the frequency will increase the likelihood of skipping releases, basically, because we may end up to deploying some releases only on canary, and then when we want to promote something, we are unsure because we already have something new ready. So it also affects other regular performance indicators, because we can imagine that our deployment metrics will give us an edge on mean time to detection, because we start gathering more data on the health of the system, as well as having a rollback strategy will definitely work well with mean time to resolution. And all of this also affects key performance indicators like GitLab.com availability and also the mean time to production, which with this new safety and automation around our deployment, we will be able to safely increase the frequency of deployment. So this is the plan. We have a working epic, which is linked here, And this is mapping the work needed for the fiscal year 21 Q3 infra KR, which is the automate manual deployment approval. And basically this epic is broken down into 4 main epics. 2 of them are the assisted phase and 2 of them are the automated phase. So assisted phase is broken down in assisted deployment and assisted rollback. The first one is about creating a consistent way to make a decision if it's time to promote a build or not. And assisted rollback is about providing a manual rollback options in case of an incident. Once we have refined those assisted technique, we will move on to the automation part with automated deployment, so that we will create a predetermined release window, and within that window, if the metrics are okay and baking time has passed, the system will automatically promote a build to production. And automated rollback is the end goal, and so the system should be able to understand if a new build is producing an outage or is degrading performance or things like that, and commence a rollback automatically. So thank you for listening. Each one of these 4 phases has its own epic, so feel free to check the status, leave a comment, and just let me know what you think about this. Thank you.